the students of class 9. Today we are summarizing the lesson structure of an atom.
Dear friends, do you know what is matter? Matter is something that occupies space and having mass is called matter. Matter having tiny particles that are called as an atom. Atom is made by some subatomic particles that are protons, electrons and neutrons.
Cannon rays. The positive rays from the gas discharge is called cannon rays. There are three types of subatomic particles: protons, electrons and neutrons. Protons. Protons are positively charged subatomic particles. Proton symbol is P. Protons derived from a Greek word. One and more protons are present at nucleus of every atom. Protons are discovered by Goldstone. Electrons. Electrons are negatively charged subatomic particles. Electrons can be either bond often atoms or free. Electrons are used in web technology. Electrons are free and open force. Electrons are discovered by J.J. Thomson. Neutrons. Neutrons is a not have any charges. It has slightly mass more than the positive charge. Neutrons was discovered by James Chadwick.
Many scientists try to give the structure of an atom. There are three. First one is J.J. Thomson's model. J.J. Thomson was born on 1856 December 18. He was awarded Nobel Prize for the discovery of electrons. He was died in 1940.
Thomson proposed the model of an atom to be similar to that of a Christmas pudding. We can also think of watermelon. The positive charge is spread all over the atom like an edible part in a watermelon. The electrons are studying like seeds in watermelon. Thomson has proposed that the atom whole is electrically neutral because the negative and positive charge is equal in magnitude. It also has limitations.
Limitations of J.J. Thomson's model tells that neutron electrically. Limitations of J.J. Thomson's model tells that atom electrically neutral, but the experiment result was carried out by other scientists. This could not explain in this model.
Let us know about Rutherford model of an atom.
First, let us know about Rutherford.
Rutherford was born on 30th August in 1871.
He was known as the father of nuclear physics
He is famous for his works on radioactivity
and discovering of cell nucleus. He got Nobel Prize in Chemistry in 1908.
He was died on 1937.
Now let us know about the Rutherford model of an atom.
Rutherford model of an atom consists of positively charged nucleus. Rutherford model of an atom contains of protons and neutrons called nucleus.
Alpha particles are directly moving. Alpha rays directly passes in a at a moment alpha rays passes straightly
Because there is an empty space in an atom.
alpha rays deviate slightly
Because the positively charged contains some occupied.
at a moment alpha particles are moving in a straight line.
That indicates that there is a space between the atom.
Some alpha particles are deviated.
That indicates positively charged occupy some small volume of space.
Some are repelled.
Because there is a positively charged which occupies some space. Rutherford model of an atom consists of neutrons and protons called nucleus, and electrons are revolving around the nucleus on the orbit by radiating energy. And also it has limitations.
Now let us know the limitation of Rutherford model. His model failed to explain the stability of an atom. The electrons are moving in a single orbit by radiating energy. When it is losing its energy, it falls into the nucleus and the nucleus is unstable.
In order to overcome the objections against Rutherford model, Bose put forward the following postulates of the model.
As atom has a positively charged sphere in a center. It contains protons and neutrons. Electrons are revolving around the nucleus, do not radiate the energy. This is nucleus, this is K cell, this is L cell, this is M shell, and this is N shell, and so on.
Atomic number, the number of electrons present in an atom. Example, boron 5, carbon 6.
The total number of neutrons and protons in an atom. Example, boron 10, carbon 12.
Let us know about the valency. The number of electrons which are gained or lost by an atom during the chemical reaction is called valency. Example, oxygen. Last orbit has 6 electrons, so it should gain 2 electrons to attain octet structure. So the valency is -2. Magnesium. Last orbit has 2 Magnesium. Last orbit has 2 electrons. It should lose 2 electrons to attain octet structure. So the valency is +2.
Hey, do you know what do you mean by distribution of electrons?
It noun electronic configuration. Assume this as nucleus, this as atom. This is nucleus. Silver color are neutrons, golden color are protons. This is K shell, this is L shell, and this is M shell.
Hey, do you know the rules to distribution of electrons?
The maximum number of electrons present in a shell given by the formula is 2n square, where n is equals to 1, 2, 3, 4, etc.
The maximum number of electrons in different shells are K shell equals to L shell will be 8 and M shell will be 18.
The maximum number of electrons that can be accommodated in the outermost orbit is 8.
Distributions will not move to the another orbit without filling the inner orbit in an atom. Do you know how to fill this atom?
Yes. Tell me one element.
Take oxygen.
Oxygen atomic number is 8.
Do you know what is the mass number of oxygen?
Yes, 16. This is neutron. Want to fill 8 neutrons into the nucleus and 8 protons into the nucleus. The oxygen number is 8. In first orbit want to fill 2 electrons and in the second orbit want to fill 8 electrons. I left with 6, so I am filling 6 electrons in second orbit. This is the electron distribution in oxygen.
Show the atomic structure of magnesium.
Yes, definitely. I have 12 protons and 12 neutrons. So the mass number of magnesium is 24. The atomic number of magnesium is 12. In first orbit I am filling 2 electrons. In second orbit I am filling 8 electrons.
Say 1, 2, nothing.
I left with 2. So I am filling last orbit with 2. This is a structure of atom of magnesium.
Isotopes, the same element having same atomic number and different mass number. Example, 6, 12, 6, 3, 13, 1H1, 1H2, 1H3. These are the example for isotopes.
Isotopes of uranium is used as fuel in nuclear reactors. An isotope of cobalt is used in a treatment of cancer. An isotope of iodine is used in a treatment of goiter.
Isotopes having different element but same mass number. Example, calcium and atom. Example, calcium and argon. Mass number is both